final session, final talk, which is going to be, I was pronouncing this Relit, but I've seen others read it. So, Charles is going to present. Yes.
Hi, my name is Charles. I'm here to talk about Relit. Hi, my name is Charles. I'm here to talk about Relit. Relit is an implementation of type literal macros for a reason. I worked on it during my last quarter at UChicago with Cyrus Omar, who's a PhD there, a postdoc there. Cool. So here is a way to construct a list using just cons operators and nil without any additional syntax. This is a little verbose. We don't tend to do this very often. Instead, here's one syntax change that we can make it a little easier to work with, adding infix operators and a form of writing nil that is more conveys lists more. But this is the way we intend to write them, is by using a list literal, right? And so this is notation specifically designed for lists. It's often built into a language where you can include arbitrary expressions in the middle of it. Now, could we do the same thing with HTML, right? Where we can just write HTML directly and have arbitrary expressions within that as well. That would be pretty convenient for developers working in web, right? Also, URLs are another piece of structured data that has a canonical representation. So it'd be cool to write that down in a way that parses to its structure at compile time. IP addresses, regexes, and SQL statements are all similarly structured data that has a standardized notation, right? So I think URLs are a really good example of this, because when I'm writing a URL, I'll always just use a string, right? I never try to use a URL builder or make a URL data type and then use constructors to express exactly what I'm thinking about. But it is structured data, and then if I ever want to go and find out what the domain name is or the port, I have to do parsing at runtime, which means that I can get a parse error at runtime. Or worse, I could try to query a website and get that error at runtime, right? So, so yeah, we need a way to reason more intelligently about these data types at compile time. And traditionally with lists, we've done that by building in those types to the language. But there's so many types here, and there could be many more in the fields of math and science. We have all sorts of notations for specifying data, that it would be absurd to ask a language designer to implement all of these notations by themselves. And so what we need is a way for a library writer, a library provider, to express notations for their data types that they're exposing. So let's put ourselves in the shoes of a library provider. We've got a module regex and a type T. This is a representation of a regex, and we can construct a regex pretty straightforwardly by using these constructors. Now this is a little verbose, right? And this is not using the standardized notation that we all have in mind for regexes. So you could easily imagine someone coming along and writing a regex.parse function that takes a string and gives you a regex. Now, this is a little unsatisfying because we get parse errors at runtime again. And merging these regexes together, if you construct one regex in one place and try to use it in another place with another regex, becomes non-obvious. So Cyrus's paper addresses a need there's a need here, right, that we want to be able to reason about these more intelligently compile time. And Cyrus's paper addresses this by introducing type literal macros, or TLMs. It's titled Reasonably Programmable Literal Notation, and it was published earlier this week at ICFP 2018. So here is Relit. Relit is an implementation of type literal macros for reason. And we've changed some of the syntax of reason. So this syntax right here is added in, this is not reason syntax, as is this backtick parenthesis, right? And this is a reason way to construct a regex, a Relit way to construct a regex using the regex notation, which is this regex notation could be defined by a library provider, right? And that's a little verbose. We can open the notation to make it a little clearer. We open the module that the notation is in to make it a little clearer. We can also, Relit allows you to alias notations, so we can have a notation lit r. We're pronouncing the $ as lit to signify that it's a literal. And lit r is defined to be regex notation, .lit regex. And then we can use lit r in the same way apply lit R to the TLN body, A or B star. Or we can open that notation directly, and then use these literals without any qualification. Now, the nice thing about this is that we can reason about responsibility in a way that we couldn't otherwise, we wouldn't necessarily be able to reason about in other AST mapping systems. So for example, in this open notation, when you encounter an open notation literal, you just go back to the most recent open notation, and then you have a direct path to notation that you're going to be looking into. If it's a notation that's just like this, then we have the same lexical reasoning principles that we have for dealing with modules, lexical scoping that we have for dealing with modules that we would have. We have those for notations as well. So here's a TLN application, and then when you go and you find the definition, it looks like this. We have notation lit regex, and we immediately get the type that it's going to return. Any application of lit regex is going to return a regex.t, which means that without looking at the parser or the lexer, we know what type it is. We don't have to, like in other macro systems, you might have to understand exactly what the parser is doing and understand how it's going to expand to see what the type is. We just have it given to us, which is nice. We also get pointed to the lexer and parser if we want to understand them more. And we get the package that they're in. Now, this is, the reason why they're in a different package is because it's a macro system, right? So we have to run code at compile time, which means that we have some code and we want to know what dependencies that code has. Now we could have them list out a bunch of dependencies of all of the runtime libraries and their dependencies for the runtime aspect of this TLM. But instead we have them just package the TLM in a parser, and we don't have to worry about that. It's much simpler. Now these dependencies here are not dependencies that are the runtime dependencies of the TLM while it's compiling your abstract syntax tree, but they are the dependencies that the expression that it generates can use. So the expansion of a given TLM application can use these dependencies, which is nice because we know that it can't use other dependencies. But it also comes important in the implementation later, which I'll discuss. So PPXs usually take a parse tree, do some arbitrary mapping to it, and return a parse tree. They're a tool in the OCaml infrastructure. Relit takes a parse tree, types checks it, gets the TLM signature, and then we get a type tree, and then it turns that into a parse tree. So Relit does this. So first of all, the implementation of Relit is a PPX with a small syntactic change to reason. So we haven't like forked a large portion, written a ton of code for OCaml or reason. Instead, we've made a small syntactic change to reason and then implement the heavy lifting with PPX that does this. So when the parsing change looks like this, we take a TLN application here, right? And then it expands to let regex equal, and then we raise an exception, relit internal def in regex, which corresponds to lit regex up here, dot apply with an error message and a TLM body. Now, this exception should never be thrown at runtime unless you forget to use relit PPX, which is why we have this error message. But the exception is there because we have to type check this code, right? That's what this is saying. So in order to type this code, we haven't expanded the macro yet. We don't know what the type is going to be. So we put a hole in here. We put raise as an exception, and it will type check against any type that it's expected. And we still have the TLM body, so we haven't lost that definition all the way. So with a definition, it's a little wacky. We parse a notation to a module, which makes sense because we were passing it around like a module, right? Opening it, aliasing it. We have the type. We have a module. I'm going to show you how to parse this. First, there is a prefix, lexer underscore, and then we have the data associated with it, which is an encoding of regex underscore parser dot lexer. Similarly for the parser, and then this dot start is encoded as a non-terminal underscore start. We have the package, dependencies, and the exception that we threw to make the encoding work. Okay, so you're a PPX. You find this code, and you have to expand it, right? And all you have is the name of the module that you're in question. Now, since we've type checked, we can ask the compiler, hey, what's the signature? And the signature contains all the information that the module itself contains, which is why we have this weird empty structs here. This is the reason syntax for an empty structure. But yeah, we don't need any information there because we've put it all into the names of the module itself. Now, one more thing I want to say about this. I forget.
Splices?
What?
Splices?
Splices, we'll get to that. So we are in the role of a PPX. We have the signature. Okay, I got another one. That's cool. Anyways, we have all the information that we need to expand it, right? Okay, so we have the dependencies tags. Remember I said I was going to talk about those dependencies? They were useful in this situation where you have a module regex which shadows the regex module in the context of the TLM application, not the TLM definition, the TLM application, right? Now, this TLM application is parsed like so. We've seen this before. And then that gets expanded to this final parse tree after the Relit PPX is done. And this parse tree opens the dependencies module. So even though it's expanding to a regex.org, it's still going to point to the right regex. It's not going to point to this shadow regex because the regex was defined as these dependencies. So this is called context independence. And it means that we don't get weird bugs where TLMs behave differently in different contexts. Okay, so a killer feature of Relit, I think, is that it can support splicing, which means that when we have a notation, we can insert arbitrary reason expressions into that notation. So here we have any DNA base, which is a regex that matches A or G or C or T, which are the DNA bases. And then we're defining the BizA enzyme to be, is it an enzyme? Enzyme to be GC followed by any DNA base followed by GC. Now this splicing can work with any OCaml expression. So this would obviously be a bug, but you could insert any kind of expression, any reason expression you could insert into this splice. And you can actually apply TLMs within this splice. So this is how TLMs compose. You can have various TLMs that are expanding to one thing with more TLMs in the middle. Cool, so why wouldn't we just use a PPX that takes something that looks like a regex and then converts it into a regex? Well, this is a tag on an AST, right? It's not a name of a PPX. So if you encounter the %regex tag and you want to know what PPX is manipulating it, it's actually pretty hard to do that. And if you have two different PPXs that are both like supporting similar tags, whichever one encounters it first, whichever one's run against your syntax tree first is the one that's going to be effective. It's going to be the one that expands it, and that's a really hard thing to reason about. So we don't get responsibility reasoning principles with the PPX. We don't get context independence generally. You could have some kind of smart way of specifying the dependencies somewhere else, but if you're just going to expand to regex.org, the PPX is going to rely on a specific module environment when it's generating. And you don't get splicing. Now, you could imagine a PPX like looking for a $ and then using the reason parser to parse an exact expression and then trying to make sure that everything works right so that it doesn't capture any variables. But Relit takes care of that for you. So, and that's a lot of work, so it's kind of weird to expect every person who's writing a notation to define their own splicing logic. So Relit does that for all of them. So, key takeaways from this talk is that typed literal macros are a way to add syntax to a language, which can be a really confusing thing to do in ways that still preserve a reader's ability to reason abstractly about the code they're reading. And Relit is kind of quirky implementation of that adds typed literal macros to reason. Okay, and we learned some lessons along the way. Type indexes are kind of hard to deal with. It doesn't work with the top loop, which is not great. That's like unfortunate. There's no equivalent to OCaml Margaret parse tree for type trees. So if you're like looking at type trees and OCaml Margaret parse tree is a library that's
Let's let you get Frederick for a moment. Make sure he hears.
OCaml Migrate parse tree is a library that allows you to write code that operates against one OCaml parse tree, like 4.0.4, and use that same code against any OCaml version because it will convert that parse tree to the one that you're expecting. We're inspecting type trees, and there's no similar equivalent to that. And this is like used to say that it won't work with Zoom, but today I found out that there is some hope in that regard. So I'm not sure I'll look into it, but yeah. So there's more things that we could implement along the way. First of all, there's no OCaml support. There's no real reason why there's no OCaml support. Relit is Reason is a project that is dealing with syntax in a way that kind of corresponds with Relit's approach to syntax. So it kind of goes hand in hand, but I want to add Relit to OCaml. And there's also no Merlin support. It would be nice to be able to see which pieces of code, when you're highlighting a piece of code, to see which ones are splices and which ones are part of the notation, right? That involves evaluating some code to get that. And so it would be nice to be able to enable Merlin to apply that the Relit PDX at edit time, so we can get more information when people are editing. There's also theory that supports pattern TLMs. So here we have a list, and we're pattern matching against the list, but using a notation that defines its structure. It'd be nice to be able to do similar things with other notations. For example, a URL, here this would be saying, no matter what the protocol is, if it's example.com, find the path, and here we're going to return some path. No matter what the protocol is, if example.com without a path, return none. Otherwise, raise a failure, right? This is looking at the structure of a URL that has already been parsed into a structured object, right? And then matching on it. So this is not supported, but it'd be great to do. And parametric TLMs, TLMs that support expanding to a type that is parametric. So this would be awesome. Like here we have like a parametric type, take A, and take A list. We can't do that. What we can do is we can like define a notation within a functor. This is a reason syntax for a functor, and then it's almost reason syntax for a functor. But but yeah, so this we can do, but it doesn't. It means that you have to pass in all the types that you're worried about. So if you want to make a map literal, you have to pass in both the key and the value types, because it's happening at the module level. It'd be much nicer to have some type inputs going on and to make that work out. So thank you. I'll just show you that we do have a README, so that goes over everything that I just said in more detail. And also, the logo is backtick, open parenthesis, close parenthesis, backtick. In case anyone didn't get that, that's very important to me. Thanks.
Questions?
You said you don't have Dune support. What build system do you support? Because as I understood it, BSB doesn't really have end-user usable support for PDXs, much less, it looks like you're using custom syntax beyond just PDXs. How do I use this?
Well, you can use OCaml C. You can also use Rebuild, which supports it.
So the feature work that you showed, is it real feature work or flying car feature work?
It's feature work that has theory that is proved behind the scenes. So it's stuff that we know how to do.
Okay.
We have not done any of it.
The patterns and parametric stuff is in the ICFP paper.
Yeah. So I saw your presentation. I was wondering how much work it would be before you can put it in.
We think we know how to do it.
Yeah, we haven't done it. So.
What about error messages?
Error messages, yeah. There's a lot of information at compile time that we have available to us, so you can imagine we could get really good error messages. Right now, they're a work in progress. Some are okay, some are really bad. None of them say nothing, I think, except for if you go and look at our current implementations of TLMs, our current like the notations that we've defined, our parsers are just terrible. But that's not a real thing. It's just bad writing parsers. So those give bad error messages, but Relit, the ones that have to do with like Relit splicing are bad. That makes sense.
You mentioned the lack of non-kernel migrate type tree. I don't think it will ever happen because type trees contain more than syntax. However, we might define an abstraction over compiler list that is portable across different versions. And for this, we need to gather the requirements, like what kind of features you are interested into, and other users of potential way to migrate type trees. So maybe we should start some shared documents to know more about the ideal interface.
Yeah, that's great.
I have a question. Do you think there's a need, and is it possible to do this at the type level as well? Notations for
Yeah, so there are typed compiler plugins, but that take a type tree representation there, but they don't return another type tree, right? So they're not manipulating the type tree. So I don't think there is a way currently to do that, but I could try something.
Type providers, that kind of thing.
No, just new syntax, but, you know.
Oh, sorry, I
I mean, like you can say,
misinterpreted what you were
well,
saying.
in Haskell, I don't like it at all, but, you know, the square brackets for list.
Yeah, I misinterpreted what you were saying.
Okay,
I was thinking we could do this at the type level instead of at the parse tree level.
Okay.
Yeah, but I don't know. It's better.
You sort of do it today with first class modules, because you can generate an expression of type module S, and that's it if it has the type.
Okay.
But you're actually not generating a type.
Yeah.
It's hard to reason abstractly about a type that you don't have any information about other than its kind.
Yeah.
So that's reasonable to get an expression.
So currently the feature is not upstream the main reason implementation.
No. Yeah.
Is there a plan to have that happen?
We haven't really talked with the reason people. I think we would be happy to do that. I'm not sure if they'd want to do that.
Yes.
Okay, thanks again.